Okay. Hello, everyone. I am AnojSubedi, originally from Nepal, and currently pursuing master's degree at the University of Quebec in Abitibi schema. My master's project is supervised by Professor Miguel Montero Girona and Professor Philippe Marchand. The study is entitled as Understanding How Tree Growth is Driven by the Climate During the Spruce Bottom Outbreak. This project evolves in the context of climate change, and we know the climate change has been altering the natural disturbance regime of forest, including the insect outbreak. In the temperate and the boreal landscape, spruce bottom is one of such insect that attains the outbreak level at the cyclic patterns of 30 to 40 years. And basically at the larval stage, this lepidopteran moth, which you can see in the screen, feeds voraciously on the tree species like black spruce, which causes growth reduction in successive years. But how the growth of trees like black spruce is influenced by the changing climate during the outbreak period. We are trying to evaluate such complex interactions by identifying the climatic variables that limits the growth of black spruce during the outbreak period of the last century in Quebec. So to this end, we compiled three categories of data. Firstly, the dendrochronological data is compiled from the 13 projects of the last 3 decades that were conducted in Quebec. With this, we have around 4,000 cross-dated black spruce trees that are spread over an area of approximately 900,000 kilometers square in more than 200 sites. And on the second part, using a special software program called BioSim, we interpolated the climatic variables of our interest. And finally, the defoliation severity for each site is identified from the defoliation map that has been produced by the Ministry of Flora, Fauna and Park of Quebec since 1968. So after having site-specific details about the growth indices of black spruce, climatic parameters, and defoliation intensity, we'll use linear and nonlinear mixed pair models to see the response on the growth with different climatic variables at different level of defoliations. So for after this, for some sites in southwestern part of Quebec, our preliminary analysis, which are in an attempt to identify the climatic variables, indicated that temperature had a significant impact on the growth of black spruce, and most specifically in those 14 sites, because we are still in the beginning phase. So we saw in 14 sites, and we found that the average temperature of May and June were highly correlated with the black spruce growth during the outbreak period. However, for the same sites, the effect of precipitation was not that significant. So we were interested to build some linear models just using temperature and precipitation, but we didn't consider the other factors, and we found that in 9 out of 14 sites, they had the negative impact on the growth of black spruce by the temperature. This shows a bit of unpredictable interactions between these interesting nexuses, but we hope to expose the unseen behind this complexity through our further analysis. So in the near future, the results of our modeling will explore detailed climatic factors and their different influence on the growth under different level of defoliation. So in overall, our study will contribute in understanding the interaction between black spruce growth and spruce bottom defoliation in the face of climate change, which can be an essential for boreal forest management. Thank you.